All right. Okay, let's stop throwing paper airplanes because we're not 5. All right, ready? So what does the gradient measure? Steepness. The slope is another word for it. Absolutely. Gradient, slope, same thing. We're measuring the steepness of a line. What is the formula for the gradient? Okay, give me coordinate versions.
Y2 minus Y1.
Thank you. Y2 minus Y1 over X2 minus X1. This is the same thing as rise over run, right? So rise over run is the same thing, but this is the difference in Y and this is the difference in X, right? So that's what we're doing. We need to measure the gradient. Remind me what Pythagoras is? A squared plus B squared equals C squared. When are you allowed to use this? Oh my gosh, what is wrong with me? I can't speak and write at the same time. When are you allowed to use this? Sorry, Judah? Right angle triangle. Guys, please stop throwing them. Okay, let's focus. So you're going to need to use this anytime you have coordinates in a triangle that make a right angled triangle. The first thing you should think is Pythagoras. Okay, when is the fancy version of Pythagoras used in linear algebra? To find the length of a line, right? So if we're going to use the fancy version of this, does anyone remember what it is? The distance is? Yeah.
X squared minus X2 minus X1 squared.
Good. Right, that is this, isn't it? This is A squared, this is B squared, this is C squared, but I'm undoing the square by putting the square root over the whole thing. This is just the fancy version of Pythagoras, right? So this is the length of a line. So if I know this coordinate here and this coordinate here, then this is my Y, this is my X, and then this is the length because this will make a right angle triangle, won't it? Right, so just make sure that you always think about Pythagoras when you're looking at things like this. What about, okay, I have written, I should have drawn that, you know what? Oh, fine, I'll just break this up. Oh no, I won't. Oh, I remember I can zoom out now. I love that function. Yeah, more room. All right. Nope. There we go. Okay, what else do I know? Oops. Nope. Okay, so what else do I know about lines? What other part of a line can I find? Okay, yes, I can find the y-intercept. I'm talking about the midpoint. Okay, so if I can find the length of a line, I can also find its midpoint. Does anyone remember how to find the midpoint? Yep, it's just the average, right? Add the x's together and divide them by 2. It's just the average. And then add the y's together and divide them by 2. The midpoint is just the average of the 2 points. Easy. Blah, blah, blah. I don't think we need anything else today. Midpoint, gradient, length of lines. That is all you need to do. Okay, so what we're going to do though is apply them to some things that may look slightly trickier, but it's the same 3 things, right? We're finding gradients, we're finding lengths of lines, we're finding midpoints. What is the general equation of a straight line? Y equals mx plus c. What is the version of it when I'm given a point and the gradient? Yep. Good. So this is going to be an equation you're going to want to use as well. If you are given 1 point and the gradient, you can use this and then expand it to get your equation. Sometimes you're going to be told that there's a piece of information missing in the middle, right? So they'll give you the answer and then say, go back and find A or go back and find B. You need to be able to work backwards as well. We did that last year. That's not new. We've already done that type of thing. Okay, there's one more thing I'm going to look at.
What's the something x plus y equation that also is very line? Do you just rearrange? You get the general formula?
I'm not quite sure. Oh, ax plus bx equals c. Ax plus by equals c. So that's just standard form. So if I have, so ax plus by equals c. That is standard form, right? And then you can rearrange it to look like y equals mx plus c. C is the same, although b has now gone over here, I guess, depending on what it is. And then a, anyway, you get the point. I'm not gonna do that, but yeah, that's the same thing. Okay, what do you know about parallel lines? Good, same gradient. Amazing. What do you know about perpendicular lines? Inverse gradients, perpendicular lines have inverse gradients. So let's do an example of that. So if I say y equals negative 2x minus 4, I want to find a perpendicular line that passes through the point 1, negative 4. How would I go about doing that? By the inverse of the equation of the gradient. So what's my new slope? Positive half, right? The inverse of 2 is half, and I changed the sign. So my new slope is half. This is my point. So I'm going to use the equation I just gave you. So what do I write? Y plus 4, well done, because it's my y minus y1 equals half x minus 1. Good. So then we have y equals half x minus half minus 4, right? Bring that across. So y is half x minus 4.5. That is an equation of a line that is perpendicular to this one and also passes through this point. Okay, not everyone is looking at me like that was okay. I know I did that quickly. Which bit do I need to go over? So here I expanded my brackets, right, which is this bit, and then my negative 4 came over here. My positive 4 became negative 4, right? And then I just put this bit together. Are we okay with that? Okay, so parallel lines have the same gradient. Perpendicular lines have inverse gradients. What do you know about a isosceles triangle? And two angles, okay. So if you're given information, if you don't have a right angled triangle, what can I do? Can make one. Anytime you can make a right angled triangle in this topic, you should. It will make your life easier. If you know that this is 4 meters and that this is 5 meters and you're asked to find the height, how would I do that? Good. This is 2.5, right? This is split in half. So 2.5, what do I do with that? Plus h squared equals 4 squared, right? This is the hypotenuse. So just be careful where you put your numbers. So then h squared is 4 squared minus 2.5 squared. So h is the square root or whatever that is, 16 minus, I can't be bothered, who cares? You get the point, right? Okay, so today we are just doing, so what we're also going to do is the skills check, right? So that should be all stuff that we're able to do pretty easily. Just a reminder of the things you should already know. Again, today is nothing new whatsoever. Everything we do today should... No, and 3.1. I've got a timetable I will give you right now. Okay. Yeah, sure. Yep. All right, so we're on page 48.